Hello student, today in this session we will going to describe the simple pendulum, okay, and what are their factors on which the simple pendulum depends. So just we are going to start this. This is a simple pendulum, okay, and here is a suppose this is a bob, okay. This is mass which is called bob, which is suspended from a fixed support that is called as a point of suspension. This point is a rigid support from where the unextensible string, this is a string, is just suspended from this point, that is called point of suspension, okay, and this is fixed at one particular point, okay. And this is a string which is just inextensible string is there, which is not stretchable. This is inextensible, okay. And this is a particle of mass m. Suppose this is a heavy particle suspended by a weightless and a inextensible string. This is the mass, the weight of just this string is just neglected here, and here also. And we can define it. What is a simple pendulum? How you will able to define it? Suppose a heavy particle called bob is just suspended by weightless and inextensible string. This string is not extensible, okay. This is just fixed, we cannot stretch it out, okay. So a heavy particle called bob, which is the mass of the simple pendulum, just suspended, is just suspended by a weightless and inextensible string and oscillate freely without any friction. This is a most important point. Without any friction of the air. Suppose we are just having this experiment, so friction should be neglected here. There should not be any friction of air also, okay. But in our actual practice, all this happens that friction just is having friction of the air is just doing their work here in order to come this bob at its rest position when you are allowed to swing. But the exact way when we are going to just perform a simple pendulum experiment, there should be frictionless condition, okay. The system should be frictionless. There should not be any friction between the air and the just the heavy particle which are just allowing to swing to and fro, okay. So and in this way we are going to just describe it, that when just from a point of suspension that is called fixed here, when a bob of a small just mass is just suspended from a fixed support and allowing to swing to and fro without any friction, then we call it a simple pendulum. And here is a just this is suppose we are just considering here OA, okay. This is the effective length, this is the length of the string, okay. This is called effective length. So and this is what this is the bob of some mass. So we'll describe one by one. Suppose OA, suppose it is suspending the condition OA. Suppose now it is in rest position, it is not moving now, but when we are just taking this to certain position at this is what we mean position, where is rest condition, and this is extreme position when we are just allowing it to oscillate, okay. So this condition when this bob is in rest position, that is called mean position. This is mean position where the simple pendulum is in rest condition, and this is extreme condition. This is extreme position where we are just making them to allow to just swinging, okay. So when we are just taking this bob to position B and allowing that to swing, it will come at this position, at the mean position. After that it will just go to AC, or again it is extreme position. Okay, so in this way it starts swinging to and fro, and just we will taking the consideration here. So there are some terms, okay, regarding that, when just a simple pendulum is oscillating to and fro from the mean position to the extreme position, and from extreme position to the mean position, again extreme position, it starts swinging. Okay, so what is oscillation? Regarding that, the first term is, what is oscillation? Oscillation is the complete to and fro motion of the pendulum. Complete to and fro means this is to, this is fro. Okay, to and fro means after it is coming to the mean position, after that extreme position, to and fro, to and fro, to and fro. Okay, so just the complete to and fro motion of the pendulum just constitute one complete oscillation. Okay, this is a definition of oscillation, that when the simple pendulum is allowing to swing, okay, completely, then the condition it is just having to and fro condition, just is swinging to and fro, and it makes complete oscillation. Complete oscillation. Okay, it will constitute one complete oscillation, one complete oscillation. Okay, the second term is the time period. What is the time period? Okay, then what is, how we will define the time period? Time period here, with time period, how will you define time period? Time period is nothing but it is the total time. Okay, it is a total time taken by the pendulum to complete one complete oscillation. Okay, it will go from here and up to this, it will come to the just a rest position, and after that in extreme position. Okay, means the total time taken by the simple pendulum to complete one oscillation. From here it is coming again here, complete oscillation. Okay, so what is the time period? How we will able to define the time period of a simple pendulum? The total time taken by the simple pendulum to take complete oscillation. Okay, complete oscillation. So this is what we call that a time period, means total time, total whatever the time it is taking from completing one oscillation. Okay, it is if it is starting from B position, then after swinging it will again come at B position, and whatever the time is taking, that is called as the time period. Okay, so this is time period. And what is the frequency? This is the first term is just time period, second term is the frequency. This is frequency of the simple pendulum. What is the frequency? Frequency is nothing but it is a number. Okay, number of oscillation. Here is a time taken by the simple pendulum to complete one complete oscillation. Here is a number. Okay, it is a number of oscillation. Number of oscillation. It is a number of oscillation. Number of oscillation just the simple pendulum is having in 1 second. Okay, suppose in 1 second, if you are just watching your clock, and in 1 second, suppose the number of oscillation from here position it just covers 4 times. Okay, 4 oscillation it is having, so the number of oscillation will be 4, so frequency will be 4. And suppose in 1 second it is oscillating 2 times. Okay, from the conditions. Okay, so in 1 second whatever the number of oscillation it is just doing, that will be the frequency. Okay, frequency of the just a simple pendulum. So how we will define the time period? The time period is defined as it is the total time taken by the simple pendulum to complete one complete oscillation. This is called as the time period. And what is frequency? Frequency is the total number of oscillation in 1 second, means whatever the we are observing in 1 second, the total number of oscillation, means from here it is coming to this place 1, again it is swinging and just coming to this place 2. Okay, like this. So the total number of oscillation just completed by the simple pendulum, that is called as the frequency of the just simple pendulum. Okay, and what about the amplitude? Amplitude is the maximum displacement of a simple pendulum from its mean position means maximum displacement means what is the displacement it is having, the total displacement. Okay, total displacement means suppose, or we can say that like this, we just go through a definition only. Okay, means what is the distance it is covering, means what is the distance it is covering in just the maximum displacement of a simple pendulum from its mean position, means from its when it is in mean position and when it is covering the distances in extreme position. Whatever the distance the simple pendulum is covering from mean position to the extreme position, that will be the amplitude, of the simple pendulum. Okay, and here is a very very important term, that is effective length, means the point of suspension. Effective length is the total length from the point of suspension to the just mass of the to the acceleration due to acceleration of the gravity of the just mass. Okay, means the effective length is defined as the length between the point of suspension, this is the point of suspension, and the center of gravity of bob, means this is the center of gravity, means this is the center of gravity is acting at the point of middle point, center of gravity is here. So the total distance between the point of suspension, the center of gravity of the mass of the bob. Okay, so this is the what we called as a just effective length. Okay, so these are the terms. So you have just get some idea about this. Now we are going to define, or we are going to explain that the factors on which the simple pendulum depends. What are the factors on which the simple pendulum depends? We will discuss it. So we are going to discuss about the factors on which the time period the time period depends. What are the factors on which the time period of pendulum depends? So here we are going to discuss the factors. Okay, that how the time period of simple pendulum depends. Okay, number one condition is scientists had just performed this experiment of simple pendulum and just find a observation that the first one is the length of the pendulum, means time period depends upon the length of the pendulum, means this effective length means time period first of all depends upon this only, effective length. Okay, how it depends? The time period of any simple pendulum is directly proportional to time period of any, just understand it clearly, time period of any simple pendulum is just directly proportional to square root of effective length. This is most important condition, that experiment has been performed and the scientist found that when the time period varies, means the time period is changing, when it is changing, when the value of the time period changing, when the length, effective length is changing, and in what manner it is changing? The square root, means it is changing with the square root of length, means directly proportional means if we increase the value of length, time period will also increase. If the value of L is increased, the time period will also increase. Okay, so how they are just got this? They have just done the experiment and they just got with the experiment that with increasing the length, effective length of the simple pendulum, the time period of the pendulum also increases, means, but the condition is it is increasing, although it is increasing while increasing the length, but increasing in that manner when we are just going to have the square root. Okay, this is a square root. If time period increases with the square root of length, suppose if the effective length is 4 centimeter or effective length is 4 centimeter, then what will be the square root of 4? It will be 2. So the time period increases with the rate of 2. Okay, with this relation the time period increases. Okay, means the time period of any simple pendulum is directly proportional to square root of effective length. In this condition, the first condition arises with the experiments. Okay, And we have also discussed it that time period is directly proportional. Directly proportional means whenever we increase the length, effective length, time period will also be increased at the same condition. But here it is a condition is a square root, means the time period varies as a square root of length. Whatever the length of the just simple pendulum, effective length will be there. At that rate, square root, with taking the square root, the value of time period will behave in that manner. Suppose we are taking that t is just directly proportional to under root L, means if the value of under root L will be 4, effective length will be 4 centimeter or whatever it is, then it will increase at under root 4. It is directly proportional under root 2, just a value of under 4 is 2, so a time period will just increase with the rate of 2. So we first of all we will just determine the effective length, and after that we will perform as the time period increase in that manner. Okay, this is what the effective length. Okay, this is the effective length. Second condition is the time period of any simple pendulum is inversely proportional to square root of g, small g. Okay, means acceleration due to gravity. This is what we acceleration due to gravity. Acceleration due to gravity. Due to gravity means, okay, the first one is this condition. Second one is t is directly proportional to just inversely, means 1 upon inversely. I am just repeating again and again that time period of any simple pendulum is inversely proportional means 1 upon. So time period is inversely proportional to under root of acceleration due to gravity, means here is a directly proportional, means when we are increasing the time period length, effective length, time period is just automatically increase in that manner. But in the second case, although the time period is inversely proportional to acceleration due to gravity, means what, if the acceleration due to gravity will increase, then the time period will decrease, and vice versa. If the time period of the simple pendulum increase, then the acceleration due to gravity decrease. But the condition is here just square root, whatever the value of g, first of all we will find a square root of that. At that rate, time period will increase or decrease. Okay, so these are the two factors on which the time period of any simple pendulum just depends. Okay, while combining all these two factors, if you are combining, suppose if you are considering this equation as 1 and this is equation as 2, if you are combining this, then the time period, time period will be just here only. Time period will directly proportional to under root L upon g. If you are adding this one, if you are adding both the equation, then it will become time period is equal to, and this proportionality constant is just equalized by the 2 pi. 2 pi is a L by g. So here is the condition we are getting. This is a expression for the time period of a simple pendulum. The t2 pi is a proportionality constant. Okay, and it is totally depend upon the just length as well as the acceleration due to gravity. Although the time period is directly proportional to effective length and inversely proportional to acceleration due to gravity, we have just discussed earlier also. And what are the condition on which the one case I am also discussing here, that these are the two conditions, that is a time period depends, but here is a condition on which the time period doesn't affect. Okay, which are the terms in the simple pendulum which is independent of the just a time period. That is this mass of the bob. It doesn't depend upon the time period. Does not depend upon the mass of the bob. This is the first condition, that it doesn't depend upon the mass of the bob. It is 4 kg or 2 kg, it doesn't matter. Okay, it doesn't matter. It will not affect any condition criteria of simple pendulum. So it is ineffective, means it is just time period does not depend on these factors. That is the mass of the bob, whether it is 2 kg or 5 kg, it doesn't matter. Okay, So, and the second one is the amplitude. Amplitude is also independent in case of time period. Okay, so and dear student, just go through. We will meet in the next video. Thank you.